We'll be looking at practice problems on a flat surface. So we'll be starting with number 1, where we are given a 6 kg block which is pulled to the right on a horizontal surface by a force of 20 Newton. The box experiences a constant frictional force of 3 Newton during its motion. So number 1, so this is the applied force to the block. They say that it is a 6 kg block and with an applied force of 20 Newton. So we get this in the statement that they will be giving us in each and every question of Newton's laws. So we take everything that is important. It's either we highlight it or we put it on the given diagram. So this is what I'm doing. I am putting it on the diagram. So Fk, which is frictional force, it is 3 Newton. So the object, it is being pulled and it moves to the right on a horizontal surface. So by identifying that there is a constant frictional force of 3 newtons, it means that the box experiences a kinetic frictional force. So the first thing that we'll do is that we draw the free body diagram. We draw the free body diagram. It is advisable for students to use a ruler to draw their what? Their free body diagrams. So when an object is on a surface, there are two forces that must be there. It is the must for these two forces to be there, which is the normal force and the gravitational force. So this is the normal force, or you can say Fn, Fg for gravitational force. And then we've got an applied force to the right? And then our applied force here, or our vector, or the vector of the applied force will point to the right. So this is Fa. And then we have what? We have a frictional force. How do we indicate our frictional force on a free body diagram? So when we indicate our frictional force on a free body diagram, we first check where the object is moving, the direction of the object. So the object is moving to the right. It means that frictional force, or the vector of the frictional force, will oppose what? Will oppose the vector of the applied force, or will oppose the direction of the what? Of the object or box. So it will point to the left. So this is our frictional force. So we are done with all the forces acting on this object here. The free body diagram will help us to do calculations of this problem. So now the first question says that we must calculate the normal force. So even though they don't ask you to draw the free body diagram, you must draw the free body diagram before answering any question. So you must draw the free body diagram and then you answer the questions. So we have drawn the free body diagram and it is correct. So now we are going to do the first question, which is calculating the normal force. And then we need to know how the object is moving. It is said that when the object is not moving, but there are forces acting on that object, it means that those forces are equal, they are at equilibrium. So now when we look at this object, it is moving horizontally only. It means that These are the only forces, the applied force and frictional force, which are not balanced. But all the vertical forces are balanced because the object is not moving up and down. So we can conclude that normal force is equals to Fg. Where do we get this? We can say that we can use the Newton's second law and say F net is equals to ma, where this m is for mass and then our a is for acceleration. Since we don't have any movement in the vertical forces or in the vertical path of the object, we don't have any movement. It means that F net will be equals to m 0, because there's no acceleration in the vertical path of this object. So now F net will be equals to 0. Since F net is equal to 0, what is the sum of the forces in our vertical path? So in our vertical path, we have what? We have F net is equals to n plus mg or Fg. So this is what? This is the normal force and the gravitational force. So these are all the forces acting on the object in the vertical path. And then now we need to choose direction, because in physics or in physical science, right, it is either you take right as positive or negative, left as positive or negative. Same applies to up and down. So to make our life easier, we are going to take down as negative and up as positive. And then we come back and look at our free body diagram. Since the normal force vector is pointing up, then it will be positive, and the gravitational force is pointing down, then it will be what? It will be negative. Therefore, n plus negative mg will be equals to 0. Therefore, n minus mg will be equals to 0, and n will be equals to mg, which then this is equals to, since we're told that our object is 6 kg, that's the mass, then we substitute 6 for m and then multiply by gravitation. So the gravitation is 9.8, and then we get our answer as 6 times 9.8, 58.8. So this is equals to 58.8 Newton. Don't forget the unit. So it is a force, so it is in newtons. Now we'll be looking at question 3, calculating the coefficient of kinetic friction. So how do we calculate the coefficient of kinetic friction? So we have this formula. You can check in your examination guideline 2021. We have this formula that says Fk is equals to mu k multiplied by normal force. So this is for friction, and then this is the coefficient of kinetic friction, and this is normal force. So since we have calculated the normal force, and then we are given that Fk is equals to 3 Newton, then what we need to do is to make mu k subject of the formula, and then mu k will be equals to, we'll divide by normal force both sides. So Fk divided by normal force. So we'll have something like this. And therefore mu k will be equals to, our Fk, given that it is 3 Newton over normal force, which we got as 58.8 Newton. As you know, these will cancel each other, and then we'll be left with 3 divided by 58.8. This will be 0.05. 0.05. We don't have a unit because N will cancel N, Newton will cancel Newton, so we won't have any unit here. So this is how we calculate the coefficient of kinetic friction. The last question is that we need to calculate the net or resultant force. What do they mean by the net or resultant force? They want us to calculate Fnet. Fnet is equals to MA. So it is either you use this side where you use mass multiplied by acceleration, which gives you Fnet, or you use this side. How do you get Fnet? So Fnet is equals to the sum of all what? Of all the forces. So now, since the object is moving horizontally, we'll now look only at the horizontal forces, which is the applied force and the frictional force. So Fnet will be equals to Fk plus what? Plus Fa. What did we say? We said that we can take right as positive, left as negative. So if you take right as positive, you need to take left as negative. If you take right as negative, you need to take left as positive. So it doesn't matter. You choose which is it right or left. You need to make positive or negative. But to make your life easier and simple, just take the direction where the object is moving as positive. So here the object is moving to the right, and we are going to take right as positive. It means that our applied force will be positive, as we have seen in our free body diagram that it was pointing to the right. And then Fk, which is our frictional force, will be negative, and because we have seen in our free body diagram that it was pointing to the left, so we're taking left as negative and right as positive. So Fnet would be equals to negative Fk plus Fa. This has mass, so we're going to say equals to negative 3 plus applied force, where we're given it was 20, and we're also given the what? The magnitude of the frictional force. So we're going to have Fnet equals to 17 Newton.